Hello, my name is George and I bring to your attention the presentation of PVS-Studio in 2019. The fact is that from time to time our users ask if there is any material that overviews the analyzer's capabilities, describes what it is, and so on. For this reason, we decided to record this presentation, in which I will tell you what PVS-Studio is, what features it has, and so on, so that you can learn about it in general. There will be many different links in this presentation. To follow them, you can download the presentation as a PowerPoint file, look through it more carefully, and follow the links given in it. The presentation will be attached in the link in the comment. Well, let's get started. PVS-Studio is a static code analyzer for finding errors and potential vulnerabilities in programs written in C, C++, C#, and Java. It works under Windows, Linux, and Mac OS. A more complete list of supported systems is presented on this slide. As you can see, we support classic compilers, for example GCC, MinGUI, etc., as well as a number of exotic compilers used in embedded development. This list is gradually expanding, replenished with new supported compilers. The PVS-Studio Static Analyzer is presented in different variations. It can be used as a plugin for Visual Studio or, for example, for IntelliJ IDEA. You can integrate it with systems such as Qt Creator or Qube. We will talk about Qube later. It can be integrated into various cloud systems, build systems like Incredibuild, and much more. We will also talk about this in more detail later. At the moment, the analyzer implements the following number of diagnostics. In C++, we are approaching 500 diagnostics. In C#, we have about 150 diagnostics, and Java is less so far. We are working in all these areas, and the number of diagnostics is constantly increasing. We pay great attention to warnings. Firstly, we have detailed documentation. Each diagnostic rule is described in Russian and English, and examples of both the wrong and the correct code are given. Our diagnostics are classified according to common weakness enumeration, as well as the coding standards of CERT-C and CERT-C++. In addition, we are now actively developing the MISR diagnostics. We support the MISR C 2012 and MISR C++ 2008 standards, and accordingly, with the help of PVS-Studio, you can check your code for compliance with these standards. Key features in general. PVS-Studio has many utilities that allow you to quickly start analyzing your code. Plugins for various IDEs, standalone version, as well as a special utility for compilation monitoring. It is needed in order to analyze the project regardless of which build system you are using. That is, you just start the assembly, this tool would collect the keys with which the compilation is started, and after that, the automatic verification of the compiled files will run. PVS-Studio also has an important function, suppress files, which allows you to view messages for just written code. All these and many other functions of the analyzer allow you to quickly start analyzing of your project. Recently, we began to pay more attention to the cloud direction. If you are interested in this topic, I suggest that you read the article PVS-Studio in the Clouds, running the analysis on Travis CI. In this article, you can find information on how to deploy and configure PVS-Studio in the cloud system. Now, let's see what PVS-Studio Static Analyzer can actually do and what defects it can detect in the program code. Let's start with a simple example. The error that we are going to examine now demonstrates well the ability of Dataflow Analysis, which is implemented in our tool. This error was found in the protocol buffers project, which is a part of a Chromium project. The analyzer immediately gives true warnings here that the condition is always true. Let's look at the code. So, there is a function which validates the date received from somewhere. This function contains a serious error, due to which the code doesn't work correctly. First, there are checks of time units, and if we do not go beyond the possible ranges, then there's a check on the number of days in a month. How does Dataflow Analysis work in PVS-Studio? At first, the analyzer sees that if the month value lies outside the range from 1 to 12, then the function exits. If the code is executed further, the analyzer knows that time month is in the range from 1 to 12 inclusively. Further, the analyzer sees that time month is the index of the array for retrieving the number of days in a month. And since a value with an index of 1 to 12 is retrieved, we discard the null element, it's not taken into account, and the value of 28 to 31 is retrieved. In the first case, time month is equal to 2. Therefore, the value for February is always extracted there. In the second case, one of the numbers is extracted, but nevertheless, this number lies in the range from 30 to 31. So the analyzer draws attention to the fact that the time-month range, which is equal from 1 to 12, is always less than range from 28 to 31. What is the matter? The fact is that the programmer made a typo. In fact, to the left of a less or equal operator should be the value of time day, not time month. The analyzer doesn't know about anything about the days or about the months of the year, etc. But nevertheless, it calculated that these expressions are true all the time, and accordingly, this is suspicious. Indeed, we see that this is really an error, and we should fix it. Let's look at other various warnings. Consider this almost classical implementation of a postfix increment. Here happens the following. A temporary variable is created, the state is copied into it, after which the iterator increases and the previous value returns. Everything would be fine if the operator returned the value itself, not a reference to the value. The temporary object will be destroyed when the control flow exits the function. Therefore, using a reference return from a function can lead to unpredictable consequences. Moving on. Here, the analyzer suspects that something is wrong, because a variable of a floating point type is initialized to a very suspicious value, 1 divided by 100. This is an integer division, so in fact we get 0. The programmer, of course, actually wanted to get 100th, but this division is not entirely correct. The error, in general, is quite simple, but it might take place and do harm, and as you see, we find such errors in real projects. Another typo, when creating a loop, we accidentally used the equals or less operator instead of a less operator, because of which an index may be out of array bounds. Such an access attempt usually results in undefined behavior. Consider an interesting unfinished code. Something is missing here. There is a variable num_byte properties, which is mentioned under a certain condition, but nothing happens to it, nothing is written to it, and no value is read from it. That is, the code is not complete. What should be here is hard to say. Only the developer can answer this question and fix the code. But this is a clear anomaly, which the analyzer warns us about. Another example is a fairly common error pattern when you need to do different actions depending on some values. Sometimes the order of checks is incorrect, and as a result, some checks don't work. Look, if the value is greater than 511, some action is being taken. If the value is greater than 1022, then completely different actions should be made. The fact is that the body of the second if expression will never be executed, because if the value is greater than 122, only the upper statement will still be executed. In fact, these conditions must be swapped, and the analyzer warns that the conditional expressions are misplaced and we have an unreachable code here. Uninitialized variables exist not only in C++, This example is written in C#. The programmer mixed up the initialization order, and as a result, the variable resource schema will be assigned by the value of the initialized variable schema. It should be noted that the schema variable is not initialized at all. It will have a default value, in this case it is null. PVS-Studio may notice anomalies in the fact that some arguments are not used. Here is a classic example. The function receives the values of height, width, and depth, but the height is not used in any way. Instead, the width is used twice. During shifts, it is sometimes forgotten that if you need to get some kind of a 64-bit value in C++, then the shifted value must also be a 64-bit variable. Otherwise, when the variable of the int type is shifted, an overflow may occur, which usually leads to undefined behavior. Accordingly, the result will be unknown. The correction of the error is that you need to explicitly indicate that we are shifting the 64-bit value. You can use typecasting before applying the shift operation, or if a shifted value is a literal, add a suffix to it. BSTR. BSTR is a data type that lives in Visual C++. It is familiar to those who work with various COM interfaces, the ATL library, and so on. This is a special string format which at the beginning contains its length, and then, in fact, an all-terminated string. Moreover, the pointer points directly to the string and not to the number of bytes. However, this is a specific format, and ordinary WCHAR-T strings cannot be passed to functions that expect a BSTR. This is incorrect because the function will actually consider it as a BSTR string. As example, it means it expects that the length of the string is written somewhere before the first character, and accordingly, the behavior is not defined here. The analyzer sees that programmer has mixed up the types of lines, the types of strings, and warns us about it too. The analyzer also performs various string analysis. For example, it finds errors when an incorrect format string is used or an incorrect regular expression is used. If it sees that something is written incorrectly, then it can issue a warning, and then a programmer can check the problem fragment and find an error. Next, the absence of virtual destructor. We hadn't found a short example, so we didn't put one in the presentation. But the fact is that for some reason, we are often asked on forums and by mail, do you detect a missing virtual destructor? So we had to make a slide to say, yes, we do have a search for virtual destructor. Everything is fine. Sometimes the code is not formatted as it logically works. This is actually due to the fact that curly braces are forgotten. A quick reading of this example gives the impression that if dot is less than 0, then all 4 operations will be performed. In fact, this is not so. Only the first expression is under condition. All others will be executed every time. In general, the analyzer knows a lot of different patterns of wrong code. And here's another one. Sometimes programmers forgot to use the throw keyword. In such cases, it turns out that an object of type stdException is created with which nothing happens afterwards. This is clearly some kind of anomaly, and accordingly, the analyzer warns us about this. Sure, there are various diagnostics for finding buffer overflows. They should take place, because if you're talking about C++, then buffer overflow is a classic error that gets into a large number of projects. Therefore, we have a whole set of diagnostic rules that detect this. In this example, we have a buffer of 8 bytes, but the strcpy function copies one more character into it, as it adds a terminal 0 to the end of the line. Thus, the terminal 0 will be written outside the array. We also have many security diagnostics. For example, one of them warns us that the memset function can be omitted by the compiler when building the release version. Because from a language point of view, this call to memset does nothing. If the buffer, after we reset it, is not used anywhere, then accordingly we don't need to fill it with zeros. The compiler can actually remove such a call. In fact, such memset calls are needed in order to clear some private data, so it can't fall into the hands of an attacker. Alas, this zeroing may not occur. The peculiarity of this error is that it is quite difficult to detect in other ways, because if you look at this call through the debugger, you will find that everything works correctly. In fact, after building in the release configuration, the private data will remain in memory. There are diagnostic rules that are associated with confusion about the priorities of operations. For example, in this case, the ternary operator doesn't work correctly. That is, it looks the one way, but it works in a completely different way. PVS-Studio identifies a large number of problems related to dereferencing null pointers. This is a pretty classic situation. Diagnostic V595 is one of the leaders in the number of warnings in various projects. Because pointers are often not very accurate, because pointers are often used not very accurate. The essence of this rule is to verify that the pointer is not used before checking for null. The example shows that the P says win pointer may be null, otherwise why to check it? But in fact, we dereference it before we check, and if a pointer turns out to be null, this will lead to undefined behavior. There is also a number of checks related to synchronization errors. Of course, one must understand that here the static analysis will be inferior to the dynamic, but it is quite capable of detecting and warning about some simple situations. Classics of the genre, potential division by zero. This rule is also based on Dataflow Analysis. The analyzer sees that first value of type variable lies in the range from 3000 to 3099. And then we subtract 3000 from it, and the resulting value from 0 to 999 is then in the denominator. This is what the analyzer warns us about. We also have memory leak detection rules. Here again, we must understand that the static analyzer is limited in its capabilities, and it cannot detect some complex cases of memory leaks. For example, in cases where the memory was allocated in one place, but one forgot to free it somewhere very far in another place of a program. Nevertheless, PVS-Studio is able to detect a very large number of situations with memory leaks, and we have a lot of diagnostics for this. You can read more about this topic by the link on the slide. Let's look at some cases of memory leaks. A simple example, we allocated memory, but if something went wrong, then we just return from the function. The memory of the object as it was allocated will remain in RAM, because no one took care of its release. There's a whole set of diagnostics, in fact PVS-Studio began with this, for finding various errors when porting code from 32-bit to 64-bit platforms. We have several articles on the site dedicated to this. Consider one example. This pointer is cast to variable of a long type. The fact is that long time in 64-bit versions of Windows is still 4 bytes, and pointers are 8 bytes wide. Therefore, here situation arises. When casting a type, the pointer will be truncated to 4 bytes, and accordingly, if this object was created outside the lower 4 gigabytes of memory, then the pointer will be corrupted. The unpleasantness of errors of this kind is that the program can function quite correctly for a sufficiently long time, because we are lucky and everything is fine. And then, suddenly, the memory is allocated outside the 4 least gigabytes, and the program may fall or begin to behave strangely. PVS-Studio and Java projects. Recently, PVS-Studio introduced support for the Java language. Therefore, here a couple of slides will be focused on errors found in Java programs. For example, integer division first occurs here, after which the result is compared with a value 0.2, which makes no sense. Naturally, we should first get the real result of division and only then compare it with 0.2. And now a simple example. The programmer wrote the wrong statement and used the logical OR instead of the logical AND. It turns out that if line is null, then we'll dereference it anyway. I'd like to refer to an article that will answer the question, is dynamic analysis better than static or vice versa? A short answer sounds like this. They don't compete, they complement each other. The static analysis is strong in one, and the dynamic analysis is strong in another. If you want to write high quality and reliable software, you must use the tools of both static and dynamic analysis. This is described in more detail in the article, the link to which is given on the slide. Just to clarify, look at an example of an error that is invisible for dynamic analysis. By the way, it's funny that we found it in a tool like Volgrind. They mixed up the last two lines, that is, go_to occurs first and only then a function call, which in fact, of course, is never called. So here, from the point of view of dynamic analysis, there is no mistake. When compiling the code, this function call will simply be deleted. Dynamic analysis will not be able to detect anything here, that is, it doesn't see the code that was deleted, although an error was clearly made here. If you check the code with a static analyzer, then it will quickly and clearly point to such things. Typos and copy-paste. The PVS-Studio analyzer is very powerful in finding various misprints and the consequences of failed copy-pasting. We find errors of this kind literally in any applications that we test when analyzing open source projects. And we have two interesting research articles on the subject, last line effect and the evil within comparison functions, that I recommend reading. You will find out how sad and interesting everything is in various programs. Just a few examples to make it clear. Look, here apparently the hand of the programmer trembled and the same thing was checked twice, although, of course, another constant should be used. This is Clang project. Or here, for example, strcmp is copied twice. The programmer had to fix something, but didn't. And we see what we got. This error was found in the GCC compiler. Here's another interesting typo example. Here, a cycle was manually expanded to optimize the speed of work. When the programmer multiplied the same type of code blocks and then began to correct them, it turned out that in one place he didn't change the 1 GDIT to 5 GDIT. And as a result, this comparison function doesn't work as it should. PVS-Studio notices an anomaly in the similar blocks and warns us that perhaps this unit is out of place here, and it really is. A simple typo situation. There are base minimum version and base maximum version. But again, it was accidentally written so that only the maximum version is checked and the minimum is forgotten. I showed only a small part of what the PVS-Studio analyzer can find. In more detail, all the diagnostic rules that we have implemented are described on the site. Using the link, you can see the list and get acquainted with diagnostics in more detail. For each diagnostics, there is an example of correct and incorrect code. Moreover, we have an extensive database of examples. For many different diagnostics, there are references to real errors we found in various open projects. By the way, we maintain a database of errors. When we write various articles, we write the errors that we found to this. We write the errors that we find to this database. And at the moment, this database already contains more than 13,000 errors. I draw your attention. This is not 13,000 warnings that the analyzer found in total for all checked projects. This is manually selected 13,000 errors. That is, thanks to our analyzer, the open source world has fixed a huge number of errors in its code. So, no doubts, there are some huge benefits from these articles. You can familiarize yourself with this database by the link on the slide. This base can be used, for example, for various scientific works, writing an article, thinking about how best to build a coding standard, and so on. In general, there is food for the mind, and if it's interesting to you, you can look and see what there in fact is in this database. It's worth mentioning that it's important to use a static analyzer correctly. We write articles about how we test various open source projects, but we must understand that this has nothing to do with the correct use of static code analysis. Yes, all of these one-time checks show the capabilities of a static analysis methodology. They show that our tool can find errors, but these are one-time actions and they don't bring the maximum possible benefit. The greatest benefit of static analysis can be achieved only with its regular use in the development process. As you know, the price of fixing a bug is highly dependent on the moment it is detected. The later the error is discovered, the more expensive it is to fix it, and as a rule, the price differs by several tens or even several hundreds of times. The essence of a static code analyzer is in its constant, regular use. In this case, the use of it can significantly reduce the development cost because a large number of errors will be detected at the very early stages of development. I recommend two small notes which you can find via these links on the slide. In order to make it convenient for you to regularly check your project, PVS-Studio has several scenarios, of which the main ones are two: automatic analysis of the changed code and night checks. Automatic analysis of modified code, also called incremental analysis, is convenient to use directly on the developer's computers. If you enable this mode, for example, in the plugin for Visual Studio, then the analysis will automatically start after you build the project. At the same time, only those errors that appeared in the new code will be present in the analyzer report. The second option is to configure night checks using the CI system. We support many such systems. You can learn more about how to configure automatic analysis on the server in the documentation. A little bit about search for vulnerabilities. How does a bug differ from a vulnerability? In general, there is almost no difference. It's just that some errors may become vulnerabilities and some may not. If in some game the pixel is drawn in the wrong color, then this, of course, is an error, but it's not a vulnerability. But there is, for example, attempt to access beyond the boundaries of an array. Now, this is, on one hand, can be a simple nuisance that corrupts some data or leads to a program crash. On the other hand, it can become a vulnerability that allows an attacker, for example, to obtain hidden data from memory. So, of course, if you detect vulnerabilities in the early stages, the cost of fixing it will be low. The worst case scenario is if a vulnerability becomes known to the whole world. It's very expensive to fix and entails both monetary and reputation losses. Accordingly, by reducing the number of errors that can become vulnerabilities, you significantly save time and money. The idea is this. There are errors that are classified according to the common weakness enumeration. These are error patterns that under adverse circumstances can turn into real vulnerabilities. Since PVS-Studio can display warnings in the common weakness enumeration format, if you're correcting these warnings, you're making your code more protected from vulnerabilities. Of course, there is no guarantee that there will be no vulnerability. For example, if you forgot to verify the password in your code, then static analysis will not help, because the logic of your program is incorrect. But, however, a large number of special cases can be detected, and you can protect yourself from them. And if so, then this must be done. Vulnerabilities are often quite simple in nature. Here, for example, is a vulnerability that was found in iOS in 2014. Go2 was accidentally written twice. How it happened is unknown, but nevertheless, the fact remains. Because of this double goto in iOS, there was a vulnerability that received its common vulnerabilities and exposures identifier. Moreover, the static analyzer easily finds such errors. If someone had checked this code with the PVS-Studio static analyzer, he would have seen at least two warnings. The first warning indicates that the code is strangely formatted, and the second, that the part of the code under the second goto is unreachable. These other examples are discussed in more detail in the article How PVS-Studio Help in the Detection of Vulnerabilities. We also develop a special diagnostic rule with the number V1010, which addresses a special case that the use of unverified input data. That is, the analyzer is trying to find situations when we got some data and use it without proper verification. A simple example. Here a string is received from the outside. Then its length is calculated without any verification and a unit is subtracted from it. The trouble comes if you have an empty string input. We will access the element of the array new name at a negative index. Let's see how this error can be repeated and reproduced. First, we will try to find it with PVS-Studio Analyzer. Here the analysis starts. Just a few seconds, and you see we have found this error. It is highlighted. So that's the wrong code. And let's reproduce this error. We start a program. We need to go to the we should go to the needed branch or code. And now we input empty string, and the program has crashed, as you see. As you can see, everything is quite simple. Because of such mistakes, in fact, there are all sorts of troubles. Okay, now let's talk about using PVS-Studio. There is a very important thing in PVS-Studio. It is called suppress base. Let me explain what it is. Suppose you have a large and old project. You take a static analyzer, check your project, and get a large number of warnings. Some to be placed, some no, but there will always be many of them. You have to edit the code somewhere, suppress false alarms somewhere. Somewhere you need to configure the analyzer. For example, tell it that this macro is consciously so cleverly written, and in fact there is no mistake here, and so on. This is a big work, a technical debt which needs to be fixed. It is very difficult. In no case can you immediately rush for all of this, because firstly, it will take a lot of time, and secondly, if you immediately correct, say, 1,000 places, that it can only get worse, because some of you will fix it, and somewhere you may introduce some new defects. So, what now? If you have so many warnings, then do nothing. Also no good. What solution do we suggest? You can do this. Say, okay, now let all the warnings found be our technical debt. We put them in a special suppression base. And now the analyzer gives no more warnings because everything that it detects at this moment is marked as so far we are not interested. Moreover, you can put this suppress base into the version control system so that later on, for all colleagues, the analysis will produce a clean log. Yes, this base is big enough, but since this is a single action, then there's nothing to worry about. Now you're kind of working from scratch, and if a new code, a new file, or so on will appear, and if the analyzer finds a defect in it, then it will warn you. Now, and when you have free time, you can return to the technical debt and gradually deal with it, correct errors, and do it in the background. This is a very good use case. Moreover, we made this system very cunning. That is, if, for example, you add something to the beginning of the file, the lines in the whole file will move. It is taken into account and suppressed warnings will not come out again. That is, you will not break anything and new warnings will only appear on new or changed code. In more detail, this is described in the documentation. There are also various ways to suppress false positive in specific lines, in specific macros, and so on, depending on your wishes. This is also fully described in the documentation. You can exclude some files or directories from the analysis. For example, if this is not your code and you don't want to check it, or if your analyzer generates positive for test, you can just exclude these files from analysis. You can also filter analysis results by diagnostic code, by file name, or by any word. If you use the plugin for Visual Studio, then you will have the function of automatic analysis after build available. That is, as soon as the file is compiled, analysis starts, and if an error appears in the code, a window will pop up warning you that something is wrong. PVS-Studio has good scalability. It uses as many threads as it finds, but it can be configured to work with fewer threads as you wish. If your project is very large and its analysis takes a lot of time, then you can integrate PVS-Studio into IncrediBuild to conduct distributed analysis on several computers at the same time. As I have already said, PVS-Studio can be integrated into various continuous integration systems, and it has a whole variety of different scenarios of how all this can be configured. That is, using CI systems, you can save the analysis results and then view reports. You can send errors by mail to people who made these errors. For this we have blame notifier utility and much more. There are plenty of options that are described in the documentation too. Moreover, it's available, for example, storing a report in HTML along with the code. I will talk about this a bit later. We have convenient online help, and there's a PDF file in case you don't have access to the network. Also, if you use the plugin for Visual Studio, you can use the interactive filtering, which I already told you about, among other things. If you're using Linux or Mac OS, on the slide we left a link for you to follow and learn more about how to configure and use PVS-Studio to work under your system. This is not difficult at all. I already briefly mentioned about quick start features. We have a compilation monitoring system. What is it for? Look, it often happens that in large projects the build system is self-written. It can be written in Python or PHP or written in something else, and of course it's difficult to somehow integrate PVS-Studio into such a system. But you want to check the project and find out what errors there are. In this case, we recommend using a compilation monitoring system. How it works? You start with monitoring utility, after which it starts tracking calls of compilers known to it. It collects all the necessary information, which files were compiled and by which compilers, with which keys the build was made, etc. Then we turn off monitoring, after which all collected files will be automatically analyzed. Thus, you can check almost any project in a few clicks. For those who use Qube, we also have integration with Qube. Qube is a tool that allows you to look at various reports in a very convenient way. Moreover, it allows you to collect the findings of various instruments into a single representation. You can configure Qube and uniformly look through reports received from dynamic analyzers and from static analyzers, or, for example, tools that show the percentage of code coverage and so on. And all this in a single common interface. Accordingly, we have an article on this topic on how to integrate with Qube and how to use the plugin for it. Yes, and you also have the opportunity to receive a report in HTML format, and the report will be together with the code. It is convenient if you want to analyze something and then post a report somewhere on the internet. This format is very suitable for this. When you click on a warning, you will see exactly the code fragment to which this warning applies. For some scenarios, this mode is very convenient. A little bit about downloading PVS-Studio. You can download and try PVS-Studio on our website. We have a demonstration version available. And if you want to try all possibilities of Analyzer, you can also request a trial key of a full version from us. Our clients. On the following slides, you can see our customers. We have clients from completely different industries. It's game dev and the financial sector and various security systems, engineering, and much, much more. If you go to our site, in the customers section, you can, in more detail by categories, find out which industries our customers belong to. By PVS-Studio, the site also has a page with a description of the two license options, and you can ask for a cost of a license depending on what you need. Accordingly, you will find out the price and then you can decide on the practicability of acquisition. Here's the links for some more details. Our product is a B2B solution and therefore we don't have individual licenses. We have an article on why this happened. If you need to use the analyzer individually for yourself or you're developing open projects, there are several options for free licensing of our product. If it is interesting for you, I suggest reading the article PVS-Studio free licensing options, where it's all described. On this point, my presentation comes to an end. Here on the screen you can find contacts and plenty of interesting links to our social media, where you can find a lot of interesting information about how we develop PVS-Studio and more. I hope you will enjoy our analyzer. Thank you for your attention. Bye.